students, welcome to this video session. The topic that we are going to cover in this session is early attempts at classification of elements. There are 118 elements known at present, and it is very difficult to study the properties of all these elements separately. So, all the elements have been divided into a few groups such that elements in the same group have similar properties. We will now describe the various attempts which have been made to classify the elements from time to time. In the year 1817, Johann Wolfgang Dubereiner, a German chemist, tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each. So, he called these groups triads. Dubereiner showed that when the 3 elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. For example, take the triad consisting of lithium, Li, sodium, Na, and potassium, K, with the respective atomic masses 6.9, 23.0, and 39.0. The average atomic mass of lithium and potassium is approximately equal to the atomic mass of sodium. You will find that groups B and C form Dubereiner triads. Now, let's discuss why was it not accepted widely. Dubereiner could identify only 3 triads from the elements known at that time. Hence, this system of classification into triads was not found to be useful. In 1866, John Newlands, an English scientist, arranged the then known elements in the order of increasing atomic masses. He started with the element having the lowest atomic mass, hydrogen, and ended at thorium, which was the 56th element. He found that every 8th element had properties similar to that of the first. He compared this to the octaves found in music. Therefore, he called it the law of octaves. It is known as Newland's law of octaves. In Newland's octaves, the properties of lithium and sodium were found to be the same. Sodium is the 8th element after lithium. Similarly, beryllium and magnesium resemble each other. We will now discuss the drawbacks of Newland's law of octaves. 1. It was found that the law of octaves was applicable only up to calcium, as after calcium, every 8th element did not possess properties similar to that of the first. 2. It was assumed by Newlands that only 56 elements existed in nature, and no more elements would be discovered in the future. But later on, several new elements were discovered whose properties did not fit into the law of octaves. 3. In order to fit elements into his table, Newlands adjusted 2 elements in the same slot, but also put some unlike elements under the same slot. Also, cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. 4. With the discovery of noble gases, the law of octaves became irrelevant. 5. Thus, Newland's law of octaves worked well with lighter elements only. Before we end this discussion, we can observe that Duberiner's triads also exist in columns of Newland's law of octaves. For example, the second column of Newland's classification has the elements lithium, sodium and potassium, which constitute a Duberiner's triad. So friends, in this video, we studied the early attempts at classification of elements. In the next video, we will learn Mendeleev's periodic table. Video session. The topic that we are going to cover in this session is Mendeleev's periodic table. Let us start with a story of a Russian scientist, Mendeleev. While he was working on the classification of elements, he found that the elements with similar properties occur at regular intervals. Based on this observation, Mendeleev gave a periodic law in 1869. How did he come to this periodic law? Among chemical properties, Mendeleev concentrated on the compounds formed by elements with oxygen and hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. The formulae of the hydrides and oxides formed by an element were treated as one of the basic properties of an element for its classification. He then took 63 cards, and on each card he wrote down the properties of one element. He sorted out the elements with similar properties and pinned the cards together on a wall. He observed that most of the elements got a place in a periodic table and were arranged in the order of their increasing atomic masses. It was also observed that there occurs a periodic recurrence of elements with similar physical and chemical properties. Therefore, he stated his periodic law. According to Mendeleev's periodic law, the properties of the elements are the periodic function of their atomic masses. Mendeleev's periodic table contains vertical columns called groups and horizontal rows called periods. There were 6 periods, horizontal rows, and 8 groups, vertical columns, in the original periodic table of Mendeleev. Out of 8 groups, first 7 groups are of normal elements and 8th group is of transition elements. Noble gases were not known at that time, so there was no group of noble gases in Mendeleev's original periodic table. The elements in each group of periodic table are similar to one another in many properties. The similar properties of the elements are repeated periodically. We will now describe 2 main features of this type of classification. 1. Elements are arranged in increasing order of their atomic masses. 2. Groups of elements have similar properties. We will now discuss the merits of Mendeleev's periodic table. It predicted the existence of some elements that had not been discovered at that time. Mendeleev left some gaps in his periodic table. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral, Eka, 1 to the name of preceding element in the same group. For instance, scandium, gallium and germanium, discovered later, have properties similar to Eka boron, Eka aluminium and Eka silicon respectively. The properties of Eka aluminium predicted by Mendeleev and those of the element gallium, which was discovered later and replaced Eka aluminium. This table provided convincing evidence for both the correctness and usefulness of Mendeleev's periodic table. Further, it was the extraordinary success of Mendeleev's prediction that led chemists not only to accept his periodic table, but also recognize him as the originator of the concept on which it is based. Noble gases like helium, He, neon, Ne, and argon, Ar, have been mentioned in many a context before this. These gases were discovered very late because they are very inert and present in extremely low concentrations in our atmosphere. One of the strengths of Mendeleev's periodic table was that when these gases were discovered, they could be placed in a new group without disturbing the existing order. Let us now discuss the limitations of Mendeleev's classification. Electronic configuration of hydrogen resembles that of alkali metals. Like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formulae as shown in the examples here. On the other hand, just like halogens, hydrogen also exists as diatomic molecules, and it combines with metals and non-metals to form covalent compounds. No fixed position can be given to hydrogen in the periodic table. This was the first limitation of Mendeleev's periodic table. He could not assign a correct position to hydrogen in his table. Isotopes were discovered long after Mendeleev had proposed his periodic classification of elements. Let us recall that isotopes of an element have similar chemical properties but different atomic masses. Thus, isotopes of all elements posed a challenge to Mendeleev's periodic law. Another problem was that the atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements. So friends, in this video, we studied about Mendeleev's periodic table. In the next video, we will learn about the modern periodic table. Hello friends, welcome to this video session. The topic that we are going to cover in this session is modern periodic table. In 1913, Henry Moseley showed that the atomic number, symbolized as Z of an element, is a more fundamental property than its atomic mass. Accordingly, Mendeleev's periodic law was modified and atomic number was adopted as the basis of modern periodic table, and the modern periodic law can be stated as follows. Properties of the elements are a periodic function of their atomic number. The atomic number gives us the number of protons in the nucleus of an atom, and this number increases by 1 in going from one element to the next. Elements, when arranged in order of increasing atomic number, lead us to the classification known as the modern periodic table. Now, we can see that the modern periodic table takes care of 3 limitations of Mendeleevs periodic table. The anomalous position of hydrogen can be discussed after we see what are the bases on which the position of an element in the modern periodic table depends. Let us now discuss about position of different elements in the modern periodic table. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. There are 7 periods in the long form of the periodic table. The elements in a period have consecutive atomic numbers. The first period contains 2 elements and it is called very short period. Second and third period contain 8 elements and are called short period. Fourth and fifth period contains 18 elements and are called long period. Sixth and seventh period contains 32 elements and are called as very long periods. The number of elements in a period is fixed by the maximum number of electrons which can be accommodated in the various shells of an atom. The maximum number of electrons that can be accommodated in a shell depends on the formula 2n raised to 2, where n is the number of the given shell from the nucleus. For example, K shell, the first period, has 2 elements. L shell, the second period, has 8 elements. The third, fourth, fifth, sixth and seventh periods have 8, 18, 18, 32 and 32 elements respectively. The reason for this you will study in higher classes. The vertical columns in a periodic table are called groups. There are 18 groups in the long form of periodic table. These are numbered as 1 to 18. Group 1 is on the left side of the periodic table, whereas 18 is on the extreme right side of the table. The elements in the groups do not have a consecutive atomic number. Friends, in this video, we studied about the modern periodic table. In the next video, we will learn about the trends in the modern periodic table.
You must have seen this setting in your house. You press the switch and the bulb starts glowing. Have you ever thought about what happens behind the wall that causes the bulb to glow? You must have heard from elders in your house or teachers in school that the glowing of a bulb is based on electric current. But what is electric current? Where it is made from? And how does this help in glowing the bulb? In today's video, we'll get to know what the electric current is and how it flows from one place to another. You must have seen a moving car. Some cars move fast and some slow. We also say that the car is moving at a speed of 40 km per hour. But what is this 40 km per hour? Meaning the car is covering a distance of 40 km in 1 hour. So when we compare anything with time, they are called the rate of that thing. Like the speed of the car, we can see the flow of water in the river in the same way and say that the water current is more. Similarly, the case with the air current as well. So it would be fair to say that current is a physical quantity which shows a relation of different parameters with time. If everything that flows has current, what will they call the current that glows the bulb when you put on the switch? We call it electric current. The rate of flow of electric charge is called electric current. If Q is the electric charge passing through a particular area in time t, then the ratio of Q and T represents electric current, which can be represented as I. The SI unit of electric current is ampere, whose symbol is A. The electric charge flows from one point to another through metallic wires. In the circuits having metallic wires, electrons create the flow of charge. The circuit should be closed from one end to another to let the charge flow. This closed path is called an electric circuit. This diagram shows a circuit in which the positive terminal of the battery is connected to the positive terminal of the bulb via wires through a switch, and the negative terminal of the battery is connected to the negative terminal of the bulb. Great, we understood the circuit. But what does this positive and negative mean? These positive and negative signs indicate the direction of current in the circuit. The electric current starts flowing from the positive terminal of the battery and ends at the negative terminal. It is also to be noted that electrons move in the opposite direction of the current. But we also know that electrons are responsible for the flow of charge and the electric current depends on the charge. Then why the electric current moves in the opposite direction? Due to the flow of electrons, a positive charge is generated in the metallic wires. The direction of this charge, which appear to be in the opposite direction of the electrons, here the direction of the electric current is taken towards the direction of this positive charge, which is formed for no other reason but due to the flow of electrons. Just as the speedometer is used to measure the speed of the vehicle, similarly in any circuit an instrument named ammeter is used to measure the electric current. Do you know a similar type of circuit is present in our homes too? But here the positive and the negative wires are not connected to the battery but are connected to the power supply coming into the house. We'll know more closely about this in the upcoming videos.